Hello, welcome to the talk of our work, Learning Attribute and Class-Specific Representation Duet for Fine-Grained Fashion Analysis. This is work from Amazon. My name is Yang Zhao. In fine-grained fashion, attribute-specific representation learning is a classical method that has been studied for years. When having a fashion image, we first have a model that transfers the image into a global representation. Then, with attribute-based transformations such as fully connected layers or attentions, the global representations are transferred into attribute-specific representations that only focus on the related features for attribute. If we have n attributes, we will have n attribute-specific representations, and then each representation goes to an independent embedding space called attribute-specific embedding space. For example, in the space of attribute color, we expect all white dresses to stay closed. Well, the attribute-specific representation learning is good in some cases, but in many other cases, it is not fine-grained enough because many attributes are actually modulable, such as color, fabric, decoration, and so on. In these cases, attribute-level learning is not fine-grained enough to discriminate multiple related fashion features in attribute. For example, this dress is modulable on attribute color. It has blue, white, and beige. So in attribute-specific representation learning, the representation cannot form decent clusters because it falls into multiple labels. Therefore, we propose a solution to learn a more fine-grained representation in class level to improve the discriminative power for fine-grained fashion features. As we designed, if we apply a class-based transformation such as class-based attention, we can have m class-specific representations if we have m classes in an attribute. And the representation goes to the embedding space of each class. Because the representation and the embedding spaces are very fine-grained, the spaces only contain positive representations that belong to this space, and negative representations that do not belong to this space, and we definitely expect these positive representations to form a cluster. Therefore, in our work, we propose the multi-attribute, multi-granularity, multi-label network, aka M3net. M3net has three key components, including an attribute-specific representation learning that learns representation for all attributes for a fashion product, and a class-specific representation learning that learns representations for all classes under all attributes. The representation in 2 granularity are all achieved by conditional attention modules, including spatial and channel-wise conditional attentions, denoted as SCA and CCA in this figure. And please refer our paper for more design details for our network and the conditional attention modules. So taking the M3net, if we have n attributes and m classes per attribute, we will learn n attribute-specific representations and n by m class-specific representations, which is actually very costly. To solve this problem, we incorporate a multi-label classification to help the class-level learning only focus on high possible classes. For attribute-level learning, because we cannot discriminate the distance between representations due to the issue of granularity, we fine-tune the representations with the loss of multi-label classification. For class-level learning, we first optimize the distance between instance representation with triplet loss, which is the blue dot and the blue arrow in this figure. And then we optimize the distance between instance and cluster centers with the prototypical triplet loss. And the cluster center is denoted as the red dot in this figure. As discussed, we have a multi-granularity training objective. The first part is the attribute level objective, which is the binary cross-entropy loss for the multi-label classification. And then in the class level, we have 2 losses. The first optimizes the distance between instances, which is actually optimizing in the local view. And the second optimizes the distance between instance and the cluster centers, which actually optimize in the global view because cluster center is a more global structure in the embedding space. We tested our work on 3 popular public datasets, including Deep Fashion, Fashion AI, and DRN. Deep Fashion is a dataset with multi-label attributes, and each attribute has around 200 classes, and each fashion product can belong to 1 to 10 classes per attribute. Fashion AI and DRN are both single-label attribute dataset. We perform fashion retrieval to validate the efficacy of our multi-granularity representations, and we compare our work with the latest fashion representation learning works. Deep Fashion is a very challenging dataset. For example, the mean average precision on attribute style is very low in previous study. While on this dataset, we observe a very large improvement. It is because our method improves the granularity of representations and also the discriminative power. Therefore, our method addresses the pinpoint for the multi-label attributes. We also observe decent improvement on Fashion AI and DRN that has single-label attributes. It shows that more fine-grained representation learning can also benefit the overall fashion discrimination, not only on the multi-label attributes. Our result has proved that the attention in 2 granularities focus on the area as we expected. For example, the attribute level attention focuses on all parts related area, including color, front decoration, and hemline in this example. But the class level attention only focuses on the class related area where the dress slit is. The retrieval performance, especially on multiple labels, is superior. MODC, our baseline, fails most of the retrieval on multiple labels, but our method retrieves more precisely. As a conclusion in this work, we propose to learn attribute and class-specific representation Duet for fine-grained fashion analysis. It is to increase the discriminative power of fashion representations. On 3 public datasets, we show superior result on task of fashion retrieval. My name is Yang Jiao, comes from Amazon. Thanks for watching.